water hardness and solubility curves as tested in the year 2024 K.C.S.E. Chemistry Paper 2. Stay tuned. Question 7, Part A. There are two types of water hardness. One type is permanent hardness caused by presence of calcium and magnesium ions. Now, before we answer any question here, let us remind ourselves that water hardness is rightfully caused by presence of calcium and magnesium ions, usually in the form of hydrogen carbonate, sulfate, or chlorides. So it happens that the last two, that is sulfate and chlorides of calcium or magnesium, are usually very stable and are not generally affected by heat. And for that reason, their presence is not easily removed by mere boiling. And for that reason, presence of the two in water makes that water sample to be permanently hard. Now, for the hydrogen carbonate, its presence in water is easily removed by boiling, where it is converted to the carbonate. For that reason, presence of hydrogen carbonate of either calcium or magnesium is what we normally call temporary hardness. So the examiner went ahead in Roman 1, Part 1 to ask us to give the name of the other type of hardness. And as we have said, there are two. One is permanent and another one is temporary. So a candidate was expected to give us the second type of hardness, which is temporary hardness, for 1 mark. In Part 2 of Roman 1, the examiner asked us to name the ion responsible for the temporary hardness that has been mentioned up here. And in our discussion, we've agreed that the ion is hydrogen carbonate. Now, the candidate had the option of writing it in symbol form like we've done for 1 mark, or you'd give us the word, and that is hydrogen carbonate. Now, the examiner was very lenient here because those of us who are biologically oriented and went for the bicarbonate ion also had their score. In Roman 2, we were asked to state one natural source of calcium ions in river water. So here we would go for calcium containing rocks to be the first source of calcium in river water. We would go for limestone as well to be a source, or gypsum is also another example that a candidate would go for as a source of calcium in river water. Now, for Roman 3 and for 2 marks, we were asked to describe how one of the methods of removing hardness is normally used, and that is the ion exchange. So we were told to describe how ion exchange can be used to remove permanent hardness of water. So the expected answer here is that Ion exchange uses a resin. This resin normally contains either sodium. It contains either sodium or hydrogen ions. So these hydrogen ions are usually exchanged. They are exchanged for magnesium and calcium ions. And this happens when hard water. This happens when hard water is passed through the resin. Is passed through the resin. So this was the expected answer for Roman 3 of question number 7A, worth 2 marks. So we would give 1 mark for mentioning sodium or hydrogen ions that are present in the resin, and the word exchange for magnesium and calcium ions for the next mark. Of course, for this part, we were able to accept equation as well. So we now move to question number 7, part B, which tested on solubility curves. In figure 5, we were given solubility curves of 2 salts here, that is potassium nitrate and potassium chloride, of course, in grams per 100 grams of water. So on the y-axis, we had solubility plus the units given, and on the x-axis, we had temperature given in degrees Celsius. Of course, this graph or this curve here is for our salt, potassium nitrate. So the graph area was a little bit larger than what our screen can capture, but of course, the part that is visible is enough to enable us answer the questions. But before we do so, let's have a look at interpretation of the scale on the 2 axes. So on the x-axis, we realize the origin is 10, and after 2 large squares, or after 2 large units, we have 20 here. In between, we have a total of 10 smaller units. So that means 1 small unit here represents 1 degree Celsius. For the y-axis, there is 20 here, and after 4 large units, we reach 40. So in between 20 and 40 that is given here, we also have 20 smaller units. So again, on the y-axis, we see a situation where 1 small unit would represent 1 gram per 100 grams of water on the solubility axis. Now with that piece of information, now we can go ahead and answer our questions that would follow. Roman 1, state the temperature at which the solubility of potassium chloride is the same as that of potassium nitrate. And this was a very easy question. A candidate was supposed to first take note of where the 2 curves intersect, where the 2 curves meet. And we see they meet here, and then you simply read the temperature. So the 2 curves meet at this point when the temperature is clearly 20 degrees Celsius. The examiner was lenient enough to give some margin of error in reading, so we were able to give a margin of error of plus or minus 1 for the 1 mark. Now, most students have got issues with units. So in as far as units were concerned, a candidate who wrote just 20 with no units got the mark. But then we had another group of candidates who would write 20 degree. Dear learner, this is an angle in maths and it can never be temperature. So this one cannot score, and therefore if you are not sure of the units, though they've been indicated here, just leave your answer as a digit. Let's have a look at Roman 2 of part B. A solution that contains 40 grams of potassium chloride in 100 grams of water is cooled slowly from 75 degrees Celsius. The first part is asking us to state the temperature at which crystals would start to form. Dear candidate, this question is simply asking us to state the temperature at which solubility of potassium chloride is 40 grams per 100 grams of water. So we get back onto our graph and read the temperature at which solubility of potassium chloride is 40 grams per 100 grams of water. If we look at this graph, solubility 40 per 100 grams of water, and then we follow it all the way to the curve of potassium chloride, we realize the temperature is exactly 40 degrees Celsius. So that becomes our answer for the question. So we now have our answer, 40 degrees Celsius. Again, the examiner was able to give a margin of error of a whole 1 degree Celsius for 1 mark. To part 2. For Roman 2, we were required to determine the mass of the salt that would form if the solution is cooled to 15 degrees Celsius. Of course, here, this is the mass of crystals. So for this question, what we would do, we would get the 40 grams that we had initially, and from it, we would subtract the mass of the salt that would remain in solution at 15 degrees Celsius. How do we get this mass that would remain in solution at 15 degrees Celsius? Is simply to read the solubility of our salt at 15 degrees Celsius from the graph. So let's go ahead and do so. 15 degrees Celsius is here, the midpoint between 10 and 20. And if you follow it to our salt, which is potassium chloride, then we realize that at 15 degrees Celsius, the solubility would be, here we have 30, and we had agreed earlier that each small unit is just 1 gram per cubic centimeter in terms of solubility. So here is 30 because it's midway between 20 and 40. Then 1 small square up makes 31. Then we have 32 and a half. So that becomes solubility of a salt at 15 degrees Celsius. That is 32 and a half grams per 100 grams of water. That's what we have read from the graph. So we carry this figure and get back to be able to answer our question. So now from 40 that we were given, when you cool this solution to 15 degrees Celsius, only 32.5 grams would remain in solution. So So that would mean that the mass of crystal that would come out is 7.5 grams. For 1 mark, so a half for the subtraction and a half for the answer. Now, to the last question. The last question informed us that 40 grams of potassium nitrate is dissolved now in 50 grams of water at room temperature. So if the mixture is slowly heated, determine the lowest temperature at which all the solid dissolves. Now for this question, the mass of water given here is only 50. So the first thing that we were to do is to calculate solubility of our salt. Remember, solubility is mass of solute per 100 grams of water. So if 50 grams of water was able to be saturated by 40 grams of our salt, we would then argue out that how much of the salt would saturate 100 grams of water, so that we calculate the solubility. Cross multiplication gives 100 times 40 divided by 50, and we get solubility of 80 grams per 100 grams of water. This would earn ourselves the first mark. And then to answer the question where we are asked to determine the lowest temperature at which all the solid would dissolve, we would get back to our graph and read the temperature at which solubility of potassium nitrate this time round is 80 grams per 100 grams of water. Now, solubility of 80 grams is here, and we follow it all the way to the curve of our salt potassium nitrate. Now, here I have 45 degrees Celsius here if you follow the x-axis. So our job here is to read the value that lies on the curve, and I can see 45, 46, 47. Remember, initially we had agreed that one small unit represents 1 degree Celsius. So the answer here is 47 degrees Celsius, which we shall then use to answer our question. So having read the solubility of 80 for our salt potassium nitrate, we realize that the temperature here is 47 degrees Celsius. Examiner again allowed some margin of error of 1 degree Celsius for 1 mark. That marks the end of our review of question 7 as tested in 2024 K.C.S.E. Chemistry Paper 2. The question tested on water hardness and solubility curves. Keep it right here for more of such reviews.